We are going to do example 5 off your homework before we start.
Unbelievable, Helen. Unbelievable.
What's unbelievable?
What do you mean?
No,
My
focus.
essay what? Someone criticized her essay really bad and she's kind of salty about it.
Feeling salty. What do the instructions say to do?
Do second derivative test.
Second derivative test, what are we finding? Points of inflection. Okay, so if I'm doing number 5, I need to take the derivative how many times? Twice. Okay, so I'm going to find f prime of x first. What is 4 times a fourth? Okay, 1x to the third minus 4x. Okay, we are now taking the derivative again, f double prime. What would we get?
3x minus 4.
Okay, from here, if you can't factor, okay, that's okay, but you should be able to factor. If this isn't a perfect root, then you can always break it up like this. Root 3x plus 2 and root 3x minus 2. Ideally, it's easier to factor that if it is a perfect square. But if it's not, that's okay. All right? Now, what are my two critical numbers? Well, remember, they're not really called that, but we sometimes call them that. What would your special numbers be to check? Negative 2 over root 3 and positive 2 over root 3. Okay, because remember, you change the sign on the second term, then you put that coefficient on the bottom, make it a fraction. Okay, now, you don't have to know exactly what those numbers are, but think about, what's the square root of 4? 2. So the square root of 3 is a little bit smaller than 2, right? So if I divide 2 by something a little bit smaller than 2, it's pretty close to 1, right? It's a little bit bigger than 1, but it's pretty close to 1. So when we put these on the number line, negative 2 root 3, positive 2 root 3, I'm going to put, that's probably like 1.1-ish. Okay, it's not exact, but we know that if you do 2 divided by like 1 point something, it's going to be a little bit bigger than 1. What could I pick between them? I'm going to do this interval first. 0, perfect. Okay, what's 0 plus 2?
2.
Positive. What's 0 minus 2? Negative. That means if I multiply those, I get a negative. What does that tell us about concavity? It's concave down. Okay, then let's say I want to pick something really big. Okay, let's say I pick the square root of 9. Okay, think about, or actually let's pick the square root of 3. What's the square root of 3 times the square root of 3 again? 3. What's 3 plus 2? Positive. Plug in your square root of 3 here. That'd give us 3 minus 2. What's that? Positive. Okay, you could pick 100 if you want, right? 100 times root 3 is really big. Add to it, it stays positive. Okay, 100 is really big. Take away 2, stays positive. So this interval to the left is also positive, which means that it goes up, down, up. I do need to label it. How should I label it? Okay, f double prime on the bottom, f on top. Because remember, the characteristics of the second derivative tell us stuff about f. Okay? Then if you had to label, if you read the last part of the question, it says identify where it's concave up and concave down. Okay, you would say it's concave up from negative infinity to negative 2 root 3, union, and then you would put from 2 over root 3 till infinity. Sure, you could also do that. If you want to just label this is concave up, that's fine too. Okay, remember that your homework is just your ability to practice stuff. So if you do it a little bit differently, I'm not going to be super, uptight about what that looks like. Okay, does that kind of help answer your question? Okay, perfect. All right, so what I'd like for you to do now is take out that pink sheet, okay, that you picked up.
And for the concave down would be?
It would be that middle chunk between the negative 2 root 3 and the 2 root 3.
Okay.
All right. So you are looking at this pink sheet right here. Okay, we are going to start on This side. Okay, so today should not be confusing unless you don't listen at the beginning, because there are going to be some things I don't want to repeat over and over again. So the most important thing is that this is not a graph of f. This is a graph of f prime. Okay, it's also labeled f prime, but if you don't notice that, it's going to seem like we're doing everything wrong. So the problem is that graph of f, we don't know. You didn't get to see it, it's not there. But instead of knowing about f, we know stuff about f prime. And so what we're going to do today is we're going to practice using our f prime graph to answer questions about f, which we don't have a picture of. Okay, so first thing, if I want f, remember this is the function we haven't seen. If I want it to be increasing, what does f prime have to be? Positive, very good. So put greater than 0. F prime has to be greater than 0. Okay, now, remember, I'm looking at f prime. So if I want to know when this graph is positive, I want to know when it's above the x-axis. Okay, so I'm going to put that right here. Positive numbers are above the x-axis. Okay, if I want to know when f is decreasing, I would want to know when f prime is less than 0. But remember, I'm looking at f prime. So if I want to know when f prime is less than 0, that would mean it would need to be where? Below the x-axis. So the first thing that I want you to do is put dots on all of your x-intercepts. So here, 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 and here. Each of those dots is where f prime switches or passes through the x-axis. So if I want f prime to be positive, okay, I would say from negative infinity until negative 4, that would be my first interval, union. And then notice that down here, my graph is below the x-axis. What were you going to say? Okay. Now look at your little middle chunk. You have a little part right here where your graph is positive because it's above the x-axis. So that would be from 2 to 4. And then your last interval would be right here from 8 till infinity. Now, notice that we're not talking about this graph's slope. We're talking about whether or not it's positive or negative, which means above or below the x-axis. Okay, now, knowing that those are my positive intervals, where would f prime's negative intervals be?
On the bottom.
Okay, yeah, from where to where?
Okay, so from negative 4
Yeah, till
to negative
2. Union. Where's my other little negative chunk?
4 to 8.
4 to 8. Very good. Okay? So if you are trying to know whether the graph that you can't see is increasing or decreasing, you would be looking for whether our f prime graph is positive or negative. Okay, now the next thing that we're going to talk about is concavity. What do we need which version of f do we need? F double prime, or f prime? I asked that in a weird way. Okay, but I meant f double prime tells us about concavity, right? What does it have to be for f to be concave up? F double prime has to be greater than 0. Okay, what about for it to be concave down? Less than 0. Okay, put a big star right here. Okay, f double prime is the derivative of f prime. Does everybody agree with that statement?
Yes.
Okay, if I'm looking at f prime, if this is my graph, what characteristic will the derivative be? The slope. Very good. So, I'm going to put right here, then it's the slope of f prime. Because remember, that's what a derivative is in a graph, is the slope. So, if I want to know where f double prime is positive, I really want the slope to be positive. So, let's come back up and look at our graph. Okay, where is my slope positive? From where to where? From negative 1 till 3. Okay, so from negative 1 till 3, union.
6 to
Yes, 6 till infinity. Because it keeps going uphill past that point. So, where we put those little markers, I want you to put X's. Okay? Those X's are going to represent something in a second. Okay, now we want to know where F is concave down. But remember, F double prime is the slope of F prime. So if I want the second derivative to be negative, I want F prime to have a negative slope. Where does that happen? Okay, negative infinity till negative 1. That's this chunk right here where it's going downhill. And then from 3 to 6. Very good. Okay, now, from here, all of the dots that you placed on your x-axis, those are all critical numbers. Because remember that a critical number is where f prime is 0. So I'm going to put right here, critical numbers are when f prime is 0. So those would be all of your x-intercepts. Oops, you can't see what I'm writing. Okay, critical numbers are when f prime is 0. So that would be each of your x-intercepts. Now remember, those can be mins or maxes if f prime changes sign. So let's focus on this first one right here. In the yellow section of the graph, before negative 4, what was f prime, positive or negative? Positive. What is it after negative 4? Negative. Now remember, this is f prime. So if f prime changes from positive to negative, would that be consistent with a maximum or a minimum? Maximum. If you're not sure, think about the slope change from positive to negative. That makes it a max. Okay, what about at 2? Think about the sign change. My graph started off below, which is negative. It switches to positive, but remember, this is slope. So if my slope changes from negative to positive, it went from downhill to uphill. What is that outline, a min or a max? Min. Okay, what happens at 4? Max, because it went from above to below. What about at 8? Min. Now, the x's that we placed on our graph are where the slope change sign. What is the slope representative of? The slope is f double prime, which is concavity. So when concavity changes, what do you call those points? Yes, points of inflection. Okay, point of inflection. Okay, so POI, POI. Okay, so all of the x's are points of inflection because if the slope of f prime changes sign, that means the concavity on f would have changed sign. Bless you. Okay, so look at the graph right next to it. Let's do another one. Okay, we're going to do 4 of these, so by the end of it, hopefully you'll get it. Okay, first one says f is increasing on, okay, so look at your graph. We know that f is going to be increasing when f prime is positive. But remember, this is f prime. So on what intervals is f prime positive or above the x-axis? From where to where?
-3 to 0.
Okay, -3 to 0 and
3 to infinity.
-3 to 0 and 3 till infinity. Okay? I'm going to go ahead and put my dots on here. Remember, these are my critical numbers. Okay, and I put them anywhere that I have an x-intercept. So this top part is positive. Okay, this part is positive. Where are my negative intervals then? Yep, down here. So where would I start? Negative infinity till? And then from 0 to 3. Very good. Now, someone in the other class was asking about, what if I use a bracket? Doesn't matter. Okay, they'll accept either one. Open is technically more right, but it doesn't really matter. Okay, and what would our because be there?
Because it's less than 0.
What's it? Yes, less than 0. And remember, that means below. This one means above. Okay? All right, next we're going to talk about concavity. But remember, concavity is f double prime. And in the graph of f prime, that's the slope. So look at your graph. Place x's anywhere that the slope changes sign. So either uphill to downhill or downhill to uphill. How many X's should you have drawn? 2. You have one up here, you have one down here. Okay, if I want to know where F is concave up, I want a positive slope. When does that happen? Till -2. And then where else is it positive? From 2 till infinity. Very good. Okay, now, unfortunately, the explanation that we wrote last time would not be accepted on the AP test. This is why. When you are explaining or justifying, you have to relate whatever you're talking about to what you're given. What were we given? F prime. So in our statement right here, you see where we wrote this? Does that say anything about F prime? No. That means that it's not complete and it wouldn't be accepted. So this is what you should write every time it's the same. Okay, because F double prime of X, which is the slope of F prime, is greater than 0. That way, you're talking about the F double prime, but you're also talking about what you looked at in the graph. You looked at the slope. That was how you answered the question. Okay, so put a little star there. That's how you should phrase that answer. Okay, concave down would be when your slope is negative. So look back at your graph. There's one chunk of the graph with a negative slope. Where is it? -2 to 2. And then you would say because F double prime of X, which is the slope of F prime, is less than 0. Okay?
Why is concave up -2?
Because on your graph, do you see how from negative infinity until -2 your slope is positive? Isn't it? Okay, so think about concavity is you're only looking at the slope of this graph. So this entire chunk of this line, okay, that I'm doing in blue, all of this graph has a positive slope. Now, you're right, for this chunk right here, it's decreasing, but it's still concave up, because remember, those aren't the same thing. If I want to increase or decrease, I can be concave up or down. So you have two different features. You have increasing and decreasing. That comes from above and below. And then you have concave up and concave down. That comes from the slope of the graph. So it's two different things that you're looking at each time. Okay, so turn, and then on here, where are my points of inflection? At the x's, so at -2 and 2. What type of critical number is 3? This one right here.
A min.
Okay, how do we know it's a min? Because how did it change from negative to positive? That makes it a minimum.
Wait, why did you scratch out the negative infinity to negative?
Oh, I was just talking to her about something, and I was trying to shade it. So it's not scratched out, it's still there. Okay, and then what type would this one be right here at 0?
Max.
Max. And then what about this one? Min. Okay, so what I want you to do is flip over to the back, look at the two on the back, see if you can do it. Okay? So let's do this. So these are F prime. You want to know about F, but you don't have a picture of that. So F is increasing when F prime is greater than 0. Now remember, that's this graph. So when is your graph from where to where? Remember, positive means like positive values. Yep. Yep. Till. Yep. Which is 2. Okay, then put your U. Where else is it positive? And remember, we found that because it was above the x-axis. That means F prime, what you're looking at, is positive. Okay, where will it be decreasing? And y'all can talk to each other and check it. Now remember, we don't want this to be decreasing. We want F to be decreasing, but we don't have a picture of it. Does that make sense? So you're answering questions about a graph you haven't seen. So when F prime, this graph is less than 0, it's going to be below. when does it stop being below though? This is zero. It is kind of legal. Okay, and then when is it negative again? When is it below again? That's normal to it, right?
Okay, so
Okay, so now, remember, we have our graph we haven't seen. Now we want to talk about its concavity. Concavity is the second derivative.
To zero,
We don't have that graph to look at. So we need to look at the slope of this graph. And that's going to tell us what the concavity is on
to
that.
infinity.
So here is my slope, positive or negative.
I'm not there
So
yet,
when?
huh?
Put an X on the graph. Okay, then what is the slope? Positive or negative? Till when?
I don't like you.
Okay, these are going to be your breakpoints for the second derivative.
Fix your head.
So when is it concave up?
Hey, hey.
Hold on, wait, no.
Don't
where
text
is
me
it?
at 8. Can you
Okay,
read my
when is your
essay?
graph
No.
concave up? When the slope of f prime is
How are you gonna
positive.
fix me?
So when is f prime
We'll
up
see.
from, till 0?
Which is that it?
Yeah. Really, it's kind of like 2.5, but it's fine. And then it's concave down from 0 to 2 for that little bit. Okay, now, so when you label these mins and maxes, okay, they're mins and maxes
No.
on f prime, because that's this graph. But remember, we don't want to know about f prime, we want to know about f. So
Hold
for
on,
f,
zero.
you're going to have mins and maxes on x intersects. And then you would look at how f prime, the graph you're looking at, changes sign. And that would tell you whether f, the graph you haven't seen, has a min or a max. So for this one, how does f prime
That is
change?
what Francie used to
From
say.
negative to
I was happy.
positive. So think about, remember f prime is slope. So my slope went from negative to positive. What part is that? A min or a max?
Wait. Concave down? Is it
How does it
2.5?
change?
I just wrote
This next x-intercept.
Precise,
Not the
huh?
slope, the values. It was positive number,
precise.
then it switched to negative number. So my original
is that the
function
only
went from
point,
a
right?
positive slope
dude.
to a negative slope. That makes it max. And then and y'all can go ahead and do both of the next two. It went from underneath negative till, which means my original function went from a negative slope to a positive slope. So what would that mean?
2? Or are you gonna
Coloring
Okay,
your
now,
graph
the
right
x's
now.
up and through are where the slope of f prime each side. But what's the slope of f prime? That's f.
Such a cute graph
What
right
does that tell us
here.
about
Look
the
at
function?
over there.
Tells us about what's concavity. If my concavity changes at these x's, that makes it what? Flexion. So your x's change to infinity.
So wait for the increasing is
So when we're writing the min and max
Negative
and point of
2 to 2?
inflection, we're talking about on the graph that you don't have.
just one, right?
Okay, so see if
With
you can do that.
without union.
Yeah.
And the decrease is negative infinity.
Yeah.
Negative 2
Yeah.
union
Yeah.
2 to positive infinity.
Yeah.
Huh? Okay, they don't have like a U in the middle of the, it have to be more like, they would need to have an undefined slope at that point, like a cusp. Then it would have been.
Wait, not yet, not yet.
Okay. Good, yeah. Okay, ask me. Okay. Okay, so
1.5, negative 1.5.
okay, so you have to think about when this is f prime. Yeah, we want to know about f. So f prime is increasing here, but that's not what it's asking you. It's asking you when f is increasing. F is increasing when f prime, which is what you're looking at, is positive.
Okay, I am doing
Positive
it. You
means
calm
above the
down.
x-axis.
This ripped today.
Rip what?
And then whenever we get to concavity, concavity is f double prime, which is
I
the
was sitting in
slope
my
of
car,
f
right?
prime.
I was sitting in my car.
So when we're
and I
answering
was
questions about
thinking I was
concavity,
gonna
that's when you
cardboard and then I put rims.
Oh, shoot. Wait, is it hanging to something?
No, no, this. I positive, but that door was really hard cleaning in. And when I guess I wasn't fitting properly, and so the thing came out, so one of the strings fell off. There was one string left.
Oh.
So now I can't make a bow out of it.
You
That's why
can't
they
do that
didn't
as
like
a whole. You don't have to
the dress, the whole dress.
But it should
like
be
you.
going negative
So.
2 to 0.
30 bucks on this.
30. Wait, just for the.
But you could just go to the car.
30 bucks on this box thing.
You are too much, honey. Now you're doing too much. You spend too much. Should have been saving for colleges, hon.
Have you been saving for college?
Exactly.
So put a dot right there.
Okay.
How do the y
Concave
values
up.
change sign?
Negative infinity.
Okay, so now think about this. This is f prime. That means that f
I
prime
rounding.
is
I'm
a
not
negative slope.
And then
To negative 2. Negative.
Because you have to think about this isn't the function you care about. You can't see the function.
union with 0 to 1.
That would be an x.
And
That
then
would be an x.
coming
That
down
equates
is
the
negative
function.
2 to 0.
And then on that dot right
Union
there,
with
put a
1
dot
to
on the
negative
x-intercept.
infinity.
How does the f prime, which
1
is the
to-
graph you're looking at, change?
Infinity.
Positive.
Infinity. Not negative.
I get my side.
Before, put your dot right there. It was positive numbers,
I know that.
negative numbers. Remember, each of those numbers is a slope. So if I had a positive slope, then I had a negative slope.
No, there's nothing in it. This is no cap.
Alright, let's see how we did. How did you do?
Good.
Good? Okay.
Pretty good.
You're freaking good. Great. Okay, your f should have been increasing for this first graph from negative 1 till 2, and then again from 3 till infinity. Okay, because f prime is greater than 0. Your graph should have been decreasing from negative infinity to negative 1, and then again from 2 to 3. Because f prime is less than 0, remember that's referring to being above or below the x-axis. Any questions about that? No? Okay, my graph is concave up when I have a positive slope, so from negative infinity until 0. And then again from, really this is like 2.5-ish. So 2.5 till infinity. Because it changes direction, that x is right in the middle.
Can you round to 3?
No, you can't.
Yes.
I mean, you could put maybe like 2.8. I don't know that I'd go with 3.
Yeah.
But, you know, whatever. Okay, now, your because there is important. You should have put f double prime.
Oh, you need it.
Slope of f prime is greater than 0. Okay, then your concave down interval would be where you had a negative slope, which would have been right here. Okay, from 0 till 2.5. Because f double prime of x, the slope of f prime, is less than 0 on that one. Okay? Alright, now on the next graph, okay, you'll notice how many critical numbers on the second graph were there. Remember that critical numbers are the same as x-intercepts. Okay, so looking at this second graph, how many x-intercepts are there? 1, 2, 3. Do all 3 of those count as a min or a max? No. Which one does not pass through the x-axis? 0. That means that 0 is not a min or a max. For f, which we don't have a picture of. Okay, what type will this one be? Min. And the other one will be a max. This will be a neither. Okay, and the reason why is because there's not actually a sign change there, so that does not count as a min or a max. Okay, your increasing should have been from negative 2 to 2, or if you broke that up, negative 2 to 0 and then 0 to 2, that is also fine. It doesn't matter. Okay? Your decreasing interval should have been negative infinity till negative 2 and 2 to infinity. You should have been concave up from negative infinity until negative 1.5, kind of a weird turning point there. And then again from 0 to 1.5. Okay, and then you should have been concave down from negative 1.5 until 0. And then also from 1.5 till infinity. Okay?
Zero be a point of inflation.
That is a great question. 0 is a point of inflection because the slope changes sign. Okay, so if you were to put x's on your graph on the POIs, you would have 3. You would have one here, here, and here. Okay?
Okay.
Alright, so switch to me for your notes, please. Okay, the notes that we did yesterday, we did the first page with the table yesterday. Okay, today we're going to finish those up on the back of that first page.
Is this one going to be on the tomorrow quiz?
That is on your quiz tomorrow, yes.
The pink sheet?
Yes. So you are getting out this right here. And then you're going to turn the page, and we're going to do that one. Okay. Part A asks when f is increasing, and actually not f, this is the derivative of g. So it says, on what interval is the function g increasing and decreasing? So think about what we just did. Okay, now remember, what is this a graph of? Is this g? G prime. So we are answering questions about a graph that we don't have. Okay, so think about part A, see if you can do that, okay? Okay, where would G be increasing? What should I be looking for in the graph? Where it's what? Above. Very good. So, increasing. Okay, where is my graph above the x-axis?
Negative infinity.
Till when? 2. Then it goes below. I gotta leave that alone. Then from 5 till infinity. So, negative infinity to 2. Union 5 to infinity. Because G prime, which is the graph that I'm looking at, was positive. It was above 0. Where would I say it was decreasing?
2 to 5.
From 2 to 5. Very good. Because, now remember, we're not talking about F this time. You got to match their letters. So if they pick G, we got to pick G. Okay, G prime is less than 0. Okay, now your critical numbers are your x-intercept markers. So put one here, put one here. And I want you to think for a second about which one is a minimum, which one is a maximum. Remember, this is G prime, so it tells you the slope of G, which we don't have a picture of. Which of those numbers, 2 or 5, is going to be a maximum? 2. X equals 2 because G prime of X changes from positive numbers, that's my yellow segment, to negative numbers, which is my pink. So from plus to minus. What type is 5 going to be? A min. Because G prime of X changes from minus to plus. Okay, your next question, part D, is asking you about concavity. Remember, not this graph's concavity, but the mystery graph that we haven't seen is concavity. What feature in G prime is going to tell us about G double prime? The slope. Very good. So if I want it to be concave up, I want a positive slope on my graph. Positive slope on G prime. Versus if I want a concave down section of the graph, I'd be looking for a negative slope. Okay, so look at your graph. Which x's have a positive slope from where to where? 4 to infinity. Because G double prime, which is the slope of G prime, is positive. Okay, I'll put that up here so you can read that. Okay, this would be your answer. The top part is just kind of like a reminder. This would be your answer. You don't have to. G double prime is fine. If you put G double prime of X, that's fine. But you don't have to. Okay, where does my graph have a negative slope? Where would it be concave down? Negative infinity till 4. Okay, and then you would say the same thing, because G double prime, which is the slope of G prime, is less than 0. Okay, place an X on your point of inflection. You should only have one. Remember, a point of inflection happens when your slope changes sign. So if I'm looking at my graph, my slope is negative, still negative, X, then positive. It is considered a cusp, but that's okay. Remember that your point of inflection is when the second derivative is 0 or undefined. So if it's a cusp like that, that means it's undefined, but it can still change signs there. Okay, so I would put X equals 4 is my point of inflection because G double prime of X, which is the slope of G prime, changes sign. Does the order matter for a point of inflection? No. Okay, if it's an inflection point, it doesn't matter if it switches plus to minus, minus to plus. As long as it changes sign, that's good enough. Okay, we're going to skip down to F for a second. Part F is asking you to find specific values. So, G double prime at 2, G double prime at 3, G double prime at 5. I'm going to go up to my graph and write them on the side. Okay, so this is part F. Asks me to find G double prime at 2, G double prime at 3, and G double prime at 5. Now, think for me for a second. We just talked about this. What feature is G double prime in this graph if this is G prime? The slope. So this is asking you for the slope at these specific points. So 2 would be right here. Okay, notice that's in the middle of a line. Can you count the rise over run of that line? Okay, count from here to here. What would I have to do? Down 2 over 2. What is that? Negative 1. That's your rise over run. Okay, now let's do it at 5. Notice we're skipping 3 for a second. Okay, go to 5. 5 is right here. Okay, you can use the endpoints of the line to count the rise over run. So if I'm here, what's my rise over run from here to here? 3 over 1, which is just 3. Okay, why would we skip 3? What happens at 3? What's wrong with your slopes on either side?
It's not equal.
They're not the same. Okay, on this side, what was my slope? Negative 1. On this side, my slope is negative 3. Or is it 2? You're right, it is negative 2. Okay, the problem is that those slopes have to match for you to have a slope at that point. So what would we say the slope is at 3? Well, put DNE, right, because it's a limit. Okay, you can think about in your head because it's a corner or a cusp. Okay, but remember, you can't say that as an explanation on the AP test. So you would say because the limit as X approaches 3 from the left of G double prime is negative 1, but the limit as X approaches 3 from the right of G double prime is negative 2. And so the problem is that those G prime limits are not the same. My slope on one side and my slope on the other side do not match. Okay, that will always happen at corners and at cusps. Okay? Alright. We may have time to go back to part G, but we're going to skip to the very last part, which you'll notice is also lettered part G, because I can't go through the alphabet, apparently. Okay, so we did this one. Okay, check. We're going on to the last part. It says, suppose G of 0 is 3. Sketch a function with all the characteristics of G. Okay, so we have G prime. We want to know what G looks like. Is everybody on the same page about that? Okay, we know what G prime looks like. We want to find what G looks like. So what I'm going to do is I'm going to make a little baby first and second derivative test on this sticky note. Okay, so ready? Where did I have mins and maxes on my graph? We already did this. This is just us putting it onto a line test.
Oh, I had a max at 2.
Okay, at 2, and where else? 5. How did the sign change if this was a max? Plus 2, minus, and then plus. Right? Because we know my function went up, down, up. You could also see I'm above, then below, then above. So that'd be positive, negative, positive. Okay, now let's talk about the second derivative. When did my slope change sign? When did I have a point of inflection?
4.
At 4. What was my slope before 4? Positive or negative? Negative slope. And then what happened at 4? It switched to a positive slope. So negative, positive. What does that tell us about F, what we're going to try to draw the picture of? It's concave down, then concave up. Okay, so down, up. So what we're going to do is we're going to use those pieces of information to draw our graph. Now, they gave you one y value. Okay, come back down here. What is g of 0? 3. That's the only point that we have to make sure that we include. So 0, 1, 2, 3. That's my only point I have. Everything else I just have to have the right shape. Okay, from 0 till 2. So 1, 2, 3, 4, 5. Okay, here's 2. From 0 to 2, I want to make sure that my graph is increasing and what? Concave down. So I'm going to increase, but I'm going to stay concave down. What is my next important number from 2 until 4? What does my graph need to do from 2 to 4? It needs to decrease how? Concave down. So from 2 until 4, I'm going to decrease concave down. Then I have to stop and I have to check and see what's going on next. The next important thing that changes is from 4 to 5. Okay, notice, am I still going downhill?
No, you're going up.
No, I'm still going downhill till 5, right? But what switched? I'm now concave up. So I need to keep going down, but I need to be concave up now. So like this. And then for my last interval, for this last little chunk, I'm increasing and up. So it would be like that. Okay, good job.
Take a picture. Come. Miss, join us.
Yeah.